Good afternoon, everyone. Thank you for joining us at today's webinar under the banner One on Education. A very warm welcome to all of you. I'm Fasiha from Orient BlackSwan. We are delighted to introduce our speaker for today, Mr. Arvind Gupta, a science expert, a toy maker, and an author. Mr. Arvind Gupta is a science expert with a difference. He did a BTech from IIT Kanpur and started working in the corporate sector, but he then quit his corporate job to pursue his passion, making science fun for children. The possibilities of using ordinary things for doing science and recycling modern junk into toys have steadily informed his work. Arvind ji has written 30 books on science activities, translated 500 books into Hindi, and presented 125 films on science activities on Doordarshan. He worked at the Children's Science Center at the Inter-University Center for Astronomy and Astrophysics, Pune, for 11 years. Under his mentorship, the center produced 8,700 short 2-minute videos on simple science experiments and science toys in 20 different languages. These videos have been viewed by over 100 million children worldwide. Every day, thousands of books are downloaded from his website, his popular website, arvindguptatoys.com. Most of us are familiar with his hugely popular TED Talk, Turning Trash into Toys for Learning. He has received many honors, including the Distinguished Alumnus Award from IIT Kanpur, and not to forget, he is a Padma Shri awardee. In this session today, he will demonstrate possibilities of doing science using the humblest and often simple throwaway materials. Arvind ji firmly believes that these toys and simple science activities bring a gleam to the eyes of children because they can do it all themselves. Thank you, Arvind ji, for accepting our invitation to speak today. And over to you now.
Well, thank you very much, Fasia, for this very, very generous introduction. And I welcome all the teachers who are from across the country. And I think you will all enjoy this session because they're going to be demonstrations of very, very simple toys, the humblest toys. In the last 2 years, because of the COVID pandemic, schools have been shut. Not that our children had access to laboratories in normal times, but these are even much more difficult times. Even progressive schools, which took children to the laboratories, are now not accessible to them. So in the last 2 years, because we had so much of digital material, 8,700 videos on YouTube, they've been watched by millions of children. I'll start with a personal story. In 1978, I took 1 year off from my job. I was working with Tata Motors, and I took a year off to work with a grassroots science teaching program in a village. And this is a famous Hoshangabad science teaching program. Now, when I went there, I said, look, now where I studied, Kanpur is very far off. Pune, where I work, is very far off. I went to the local bazaar. It's a local hut, a weekly hut, where people display all their wares on the road. There could be bangles, there could be ticklies, bindis, there would be small mirrors. And I said that I'll buy one specimen of every artifact and then see possibilities of using them for teaching science, because then it would make sense. And one thing which I found was this cycle valve tube. Now, this is where you pump in air in a bicycle, you use a little bit of this cycle valve tube. Now, this may cost, at that time, it was 10 paisa per fit. Even today, for a 250 gram packet, it's about 30 rupees, 50 feet of this. And if you take two of these, two bits of the cycle valve tube, you can just loop them together, 2 matchsticks, and you get a very nice, you can make it's like an angle. It's an acute angle, right angle, obtuse angle, straight angle. You can depict any kind of angle. This is like a universal coupling, as you can see. right from 0 to 360 degrees. If you had 3 of them together, you could loop them and you would make a very nice triangle. And because matchsticks are mass produced in a factory, so all these angles are 60 degrees. It's automatically a quadratic triangle. So children, for the first time, see what's 60 degrees. If you take 4 of these, you make a very nice square, a pentagon, a hexagon, all these two-dimensional shapes. Now, they have some very interesting properties. If you look at the hexagon, for instance, if you just pull this out, this becomes a rectangle. If you just give it a push, it becomes a parallelogram. But this is like an amoeba, which is constantly changing its outer profile. It's very, very flexible. Even the pentagon, if you just pull this out, it becomes a boat-shaped, it becomes a trapezium. And if you push this in, this becomes a house-shaped, a combination of a square and a triangle. The square may look very square and prim, but if you just give it a push, this becomes a rhombus. It looks like a barfi, but very, very shaky. And now you give a child a triangle. And no matter what she does, a triangle remains a triangle. So why study about triangles? Because triangles are the only rigid polygons. If you look at a house in a village, the roof would always be triangular because it can take the load off the roof of the corrugated sheets. But if you were to make a roof with square members and you put something on top, it would just collapse. You can't make a bridge with square members because the train would come, it would be a very, very shaky bridge indeed. And now you can just poke a third matchstick and make it into a T-joint. You just make a hole with a needle and push a third matchstick. And if you were to push all the 3 legs into the triangle, you would make a tetrahedron. Now, we've just seen that the triangle is the only rigid polygon, and the tetrahedron, because it's tetra means 4, hedrons means made of triangles, made of 4 triangles, is the strongest structure found in nature. Very, very strong. And once you have these basic things, you can similarly make a joint of 6, you can make a joint of 4, and with these, and with matchsticks as your elements, you can make all kinds of modules, all kinds of 3D. Now, this is what I'm holding is a prism, and if you put a tetrahedron on top, it looks like a little temple. Or if you take the cube, for instance, this is the cube, and if I put a roof on top, a pyramid on top, it looks like a village house. So the idea is, you can also make, this is called as an icosahedron. Ico means 20 triangles. And the nice thing about this is that you can flex. Now this becomes like an igloo. The nicest thing, if you look at the world's most expensive mechano, if you cut all the frills and fancies, what is a mechano anyway? There are certain couplings and there are certain elements. And all these couplings, joint of 2, 3, 4, 5, 6, 8, you can all make with the cycle valve tube and the matchbox at home. Without the matchbox, you can't light the home fire. So this is 78. This is almost 44 years back. I was very young at that time, very young engineer, 25 years old. And this, I thought, was much more interesting than working in a factory. And I've just continued doing that. And today I'm going to show you many, many more possibilities of making very interesting things using simple material. And they're much more relevant in COVID times because you don't have access to expensive laboratories. Now, this is a pencil with a rubber on one end. Many children have it. If they make a mistake, they can erase it. So there's the eraser on one end. So if you make just 5 or 6 notches away, V notches, slightly deep, then you take a card sheet, make a rectangular fan, cut a hole, and push a pin. You can see there is a black stopper. It's a piece of rubber. Otherwise, this fan will fly away. In my other hand is a broomstick. It's a piece of broomstick. And if I rub this, something very amazing happens. This is a very, 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 very beautiful spinner. And just just made from a pencil. This is a 100-year-old toy. It's a darling of every physicist. Every inspired physics teacher would show this toy to the class. I'm going to show you some toys with straws, and this is a very interesting one. Now, you just take an ordinary straw and press one end, flatten it out. Then with the help of a scissors, you cut a point. It's like a point. Now this, if you see, this looks like a baby crocodile's mouth, and this becomes a reed. I'm going to blow through this, and this makes a very loud noise. You're not able to see how the sound is produced because the reed was in my mouth. I'm going to keep this outside. This is where the reed is. And I'm going to suck in air now. And as I suck in, this part opens and closes at a very fast rate. It vibrates. For production of sound, we require vibrations. Now, we don't need to mug this up. Children can actually experience this. And what they experience goes in very, very deeply. This brings me to two cardinal principles of education. I'm just rephrasing them because they're very well established. The first principle is the children learn from the concrete to the abstract. From very, very concrete things, little children need a lot of experience. They need to touch, they need to feel, they need to taste, they need to pull things apart, put them back again. They need a lot of experience with different kinds of materials, how to put them together, how to take them apart. So this is the first principle, from the concrete to the abstract. And the second principle is from the near to the far, from local to global. You always start with things. You don't take kids to a very fancy laboratory with burettes and pipettes and fancy glassware, plasterware, because children will be out of their depths. Start with something which is available in the household, which they're familiar with. And if you can show possibilities of science to them using very ordinary materials, and they know that science is everywhere. So these are the two principles. Here is another one, a very nice experiment. Here is a fat straw. And what we did was just cut a few deep notches. There are V notches, you can see. V notches. And then there is a thread over here. I've just woven the thread through this and tied a knot over here and put some golden tape because it's visible. That's it. Now, if I pull this, it's like a finger. It's like a robotic finger. The plastic curves just like a finger. If I release, it has a restorative force and it goes back again. And there is a third one, a very nice toy with straws, and which is a spinner. Now here is this, we have a fat straw, and we just sealed both the ends with blue tape. After that, nip the top right corner and the bottom left corner. So there are two diametrically opposite holes. There is a hole over here and there's a hole over here. And then fold this in half and nip both the corners and you get a square hole in the middle. Now this green thing is my blowing straw. I put this inside and there is a hole over here through which the air will come out. I shut this end and bring the spinner on top of it. As the air ejects from the two diametrically opposite holes, it gives it a torque. It makes it spin. If I reverse the direction, you would observe that the direction of rotation of this spinner also reverses. This is also a verification of Newton's third law of motion, that every action has an equal and opposite reaction. As air jets out of this hole, it gives it a kick in the opposite direction. And that's what makes it go round and round. A very, very simple toy, a fun toy, the same thing made with a fruity. This is a fruity pipe, an ordinary straw. Children always like toys which spin, which make sound, which jump, where there's some movement, some dynamic element is always, it makes a lot of, it's a lot of fun for children. Now, in the Hoshiarabad science, we try to make different kinds of motors. In the 9th class, 8th class, all children study about electricity, and children read about the principle of the electric motor. Rare is a child who ever makes a motor. Now, this is the simplest motor on earth. You just need a battery. It's a 20 rupee battery. This black thing is old cycle tube, and these are two safety pins. And this is like a broad rubber band, and both these safety pins are snug to the plus and the minus of the battery. So this is 1.5 volts across both these terminals. And this is a ring magnet. These are ferrite magnets. It could be square, it could be rectangular. The shape is immaterial, but they're very, very cheap, just about 1 rupee each. And then you just need 1 meter of insulated copper wire used for motor rewinding. I'm just going to put this coil. Electricity will flow through this coil. This will become an electromagnet. And there goes the motor. It takes less than 10 minutes to make a motor like that. How many children in our schools ever make a motor? Even engineering students. 5 years I studied in IIT Kanpur. Much later, they gave me a Distinguished Alumnus Award. And the electrical engineering department wanted to honor me. I said, look, I studied here 5 years, but I discovered the beauty of the motor much later on when I made it myself. Now imagine, in a typical middle-class house, without the motor, life would come to a standstill. The mixer has a motor, the fan has a motor, the cooler has a motor, the AC has a motor, the fridge has a motor. It's the motor which drives the pump which fills water to the overhead tank. But none of our children ever makes a motor. If you have a battery, even at these global rates, it just costs 5 rupees to make this motor. So this is not a rich man's toy. The poorest child can make it. And if children make a motor like this, trust me, they're going to sleep with it. And then the theory which they have just mugged up to spit out in the exam would become much more starkly clear to them. They would understand it so much more better. So the theory will fall into place, but they need to make a motor like this. Right? Since we documented this, we made it in 1990, this is 32 years old, but millions of kids have made a motor like this. I will show you another toy. Now this is more like this is a generator.
Sir, I think you're on mute.
Arvindji.
Yeah, sorry. Thanks. Sorry. So this is something called as a syringe generator. You can see the syringe over here. It's a 10 ml syringe, and these are 2 magnets. These are neodymium magnets. They're so powerful that I can't separate them. And that's what makes this toy work. And I just put these 2 magnets inside, and you can see that they are reciprocating. Inside the syringe, I just put a stopper over here, a rubber stopper. Now, this is copper wire, insulated copper wire, 36 gauge. The more the gauge, the thinner the wire. And how many turns of this? This is a 1,000 turns. Because the more the number of turns, the more is the EMF, electromotive force, which is generated. So 1,000 turns, and the start and the end, you scrape, and you attach it to a LED. This is a small LED. Now, if I shake the syringe, what would happen? The magnets will go left to right, they reciprocate. It's like a strong moving magnetic field, which will cut these lines of forces, and there would be a small EMF. Look at this. Can you see this sparkling LED? We are generating electricity. Even if it's a 1,000 megawatt generator, the principle does not change. Imagine a village girl in UP or in backward Bihar, where there are hours of power cuts. Still, if a girl is able to light up a small LED, it is truly empowering. The girl will feel that today I've lit up an LED. Yeah. Tomorrow I will endeavor to light up my village. We have about 20 models, different kinds of generators, wind generators, etc. They're very, very popular, but as simple as that. Now, once children make these models, then the electromagnetic laws of induction, the Fleming's rule, all these children just parrot up and regurgitate in their exams would become much more starkly clear to them. I'm going to show you a very interesting toy, which one has a lot of credit. Now, this is a piece of rubber. And what you see are 4 magnets over here. There are 4 magnets here. And I've got a pen over here with 2 similar ring magnets. Now, the front magnets are opposite poles, so they attract. So if this is north, this must be south, so they attract. The lower ones over here, the one at the end, and these are opposite poles, so they attract. They repel. They're similar poles, both north or both south, so they repel. So the front ones pull the pencil, the rear ones push it. Now, if I put my finger over here, you can see that this is just hanging in the air, and I can actually twirl it, give it a twirl. But if I touch, this is a piece of CD, a cut DVD or CD, and it's levitating, it's spinning, and you can try with this. Very soon, many parts of the world, there are maglev trains, magnetically levitating trains. And this is something which costs 10, 15 rupees, very affordable for a child. If a child makes a toy like this, a levitating pencil, it gives them great insights. And what a nice toy to play with. Well, we make a lot of simple paper toys. All our old newspapers and magazines, we cut into little squares. This is the cheapest paper from a newspaper or old magazine. Now, if you take 2 of these, if you just take a square, put the opposite ends together, you'd make a triangle. Now, fold the triangle again, and you'd get a small triangle. You'll get it's like the letter V, V for van, V for victory, and they look like the ears of an animal, 2 ears. And what I'm just going to do is to tear them to make 2 long and slightly rounded ears, and then fold the front one and the back one. And in less than 10 seconds, I have Mr. Rabbit. This rabbit's long ears, it's his mouth. These are the 2 front legs. I hold them just below the legs and grab the tail. And if I move the tail, you can see it's like a flapping ear rabbit. When I was a child, 5 years old, I made toys like this. And these are sustainable. 50 years down the line, 100 years down the line, all these He-Man, and Barbies and Skullman, all these very violent and sexist toys, they're unsustainable by mother. They would disappear, but kids would still be making a toy like that. Right? And similarly, you have Well, the same square, and this is now documented with this square, you make this flat. Kids in Japan have been making this, no glue, no scissors, just a square and your 10 little fingers, and you make such an unmatched 300 years. This is documented history. Now, origami came from Japan, and the whole, if there is a religious festival, the whole family eats rice cakes, they pray, and they sit down and they fold paper. And this is unmatched for 100 years. Just a square piece of paper, no glue, no clips, no scissors, and you make this pen. Now, what we did was, we took the Japanese grain, and what we did was just put a fan on the tail. This is a refill, a small ball pen refill. If you have an old ball pen refill, don't throw it away, because you make 10 of these birds. There is a pin rotating. The refill is the bush or the bearing. This is the pin, and with a little strip of paper. And at the end of the tail, and this is what this does. This is a fan-tailed bird. Absolutely delightful. It's aerodynamic. Whether you are old, whether you are young, it's just made from scraps. It costs no money. You can't buy this online. But if you're clever, you can make it yourself. Now, one of the very nice experiments which I like was done about 35 years back at the Vikram Sarabhai Community Science Center in Ahmedabad. What they did was they gave every child an empty matchbox, same brand, so they're exactly the same size. And the question posed was, you keep this matchbox with you for a week and fill in with one specimen of each thing, but they should be different. And a child who packs in the maximum number of things would get a prize after 1 week. Now, the first time the children went back home and they started looking for small things in their little world. And one child went to the kitchen, the mother was making poha, he took a mustard seed and put in. He put a rice grain and put in. He put a cumin seed and put in. He just put a hair and put in. A sliver of thread. Well, can you imagine? A child was able to pack in close to 200 things in a matchbox. Now, this is what science is. Science is not this gleam and expensive materials and apparatuses, which I've been to 1,000 schools. And every time I say, I'd like to see your science lab, and I'm taken to a lab with the gleaming glassware, plasticware, and if you're perceptive, you see a grime of dust on all that apparatus, because all that apparatus was meant for the inspector, not the children, unfortunately. But this is it. Critically looking in the world around you, you can do great science with simple material, right? Because science is a viewpoint. How critically you examine phenomena, that's what science is all about, right? There are 2, 3 more toys using matchboxes, and this one is a very lovely one. Just take an ordinary matchbox, and what I've done is I've just stuck a clip over here and a clip on the back side. Taped it so that the clip is just jutting about 2 mm outside. And then just weave a thread through it. The drawer is outside, so as to all the weight is on one side. And I have this thread. I'm going to hold this thread very tight and let it go. It comes down in a very, it's like a shimmering fish, it comes down. You can reverse it. Very simple. All the weight of this is because of friction and because of gravity. Another very interesting toy using the matchbox is a matchbox frame. I put a matchbox and a piece of thread. And there's just one piece of thread, and I'm going to use my right hand, move my right hand, and you can see the matchbox is going on these rails. It doesn't come back, so I've got to pull it back again. Here it goes. It's like a traveling. And if you stick a picture of a bunny rabbit on this, it will look like a bunny rabbit going hop, hop, hop. If you stick a picture of Thomas the Engine on it, it look like an engine going. Very, very interesting. I'm going to show you something which I really like. And this you can recognize. This is a woven sack in which wheat comes, rice comes, fertilizer comes. So this is a woven sack. What I've just done is taken about 12 strands, which are about 30 centimeters, a foot long, and tied a knot here. There is a knot here. So I have about 20 strands of plastic sack and tight, and then I'm just going to rub them with my thumb and my index finger. And look, see, because they've all got static electricity. They are just repelling each other. If I bring my hand, can you see? It's attracted towards my hand. My hand has an opposite charge. Imagine this. I wish our people in the educational institutes like the NCRT and the ACRT, who always talk about the gold leaf electroscope. In the 3,000 schools I've visited, I've never seen a gold leaf electroscope actually work. But this works like magic. How to discharge it? I just touch it to my body, and all the charge goes in my body. Once again, if I rub it, well, I can again. Imagine if a child brings a woven sack, a torn woven sack into the school. The entire school can do the experiment and take the experiment back into their homes, into the community. I think this is probably the world's best demonstration of static electricity, what you could do with very, very simple things. This is something called as here's a cyclic model. It's called as a flexible. There are 4 pictures over here. You see butterflies, you see frogs, you see snakes, you see eagles. 4 pictures which come in a sequence, one after the other. And we can weave a story in them. Insects, butterflies, insects are eaten by the frogs. Frogs are eaten by the snakes. Snakes are eaten by the butterflies eaten by the frogs. Frogs are eaten by the snakes. Snakes are eaten by the eagles. It's like a little food chain. And science is full of chains and cycles and life cycles. And if you had a piece of A4 size paper like this, no glue, just a scale and a pencil. In 3 minutes, you can form this. There's no glue in this. And imagine, you can think of cycles, you can think of the cycles of the seasons. Right now, it's the winter. Winter would be followed by the spring. Then would come the harsh summers, followed by the monsoons. Four cycles of the season. 4 main seasons in India, you could depict them. You could put the life cycle of a frog, life cycle of a butterfly. No, it's just limited by your imagination. And this is not just limited to science. If you look at history, history is all about timelines. If you look at the Maratha period, who was the first Maratha emperor? Who succeeded him? Who sat on the throne next? Right? Draw the pictures, write the names, write the dates, and this makes history or science much more alive. And just a piece of A4 size paper. If it's printed on one side, the printed side would get camouflaged. That's what you do with this. If you have a small piece of paper, you make a small flexible. If nothing else, it's your grandmother's birthday, right? Happy birthday, grandma, and draw some flowers. And your grandma would be twiddling her thumbs. So these are the kind of possibilities which this holds. There's something else, it's called as a 14-page unending book. Now, you require 2 squares of paper like this, and you require a little bit of glue in this. Now you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 is the last page, and it starts again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5. Now imagine, this is such a nice picture book. Every child has a favorite story, which you can hear 50 times and not get bored with. So every child chooses a different story, and they divide this 14 steps and they illustrate it. And then every child has a rotating, moving, dynamic picture book. Each one is a different picture book. And it doesn't cost much money to do this. Well, there are some very interesting. Now, this is from an A4 size paper. You could make 4 of these. And this is called as a clapper. And what does this clapper do? That's what it does. You hold it like this, and you can. No glue, no scissors. Very nice. It makes a sound. And similarly, you have this, as you just saw, the rabbit, the flapping. This gift comes from a girl from China, and this is a flapping butterfly. It just simulates the opening, and these are all 2-minute toys. Little children want early gratification. They can't wait for 5 days for the results to seep in. This in 5 minutes, 10 minutes, they finish the project, and they can see it working. And you don't need to give numbers to it, because if it is not working, it just means that they have to work harder to make it work. Children like dynamic toys. Look at this. This is a thin fruity straw which goes into an ordinary straw. And this is a crane. Similarly, you could have a one with a flapping butterfly. Another very interesting toy with a card sheet is this. Look at this person. He's doing exercises. We can also call him a drummer. Look at the back side. There is a broomstick, a bit of straw over here, and a small card sheet. That's it. But a very, very dynamic toy. All these are documented on my website. One of the toys I really want to show you is this. This comes from the VSO Science Teacher's Handbook, which is again on my website. But this is, if you take an A4 size paper, this is half the A4 size paper. Just with half the paper, you can make the scale model of the skeleton. Here you can see it's a skull. This is the rib cage. This is the pelvis. This is the tibia, fibia. The human body has 200 odd bones, but a third class or a fourth class child, all you just need is a piece of paper, glue, and a scissors. And piece by piece, they can put this together. It's a very nice scale model. It's also very useful to explore some other very deep biases. Then you can ask children, tell me, is this a skeleton for man or a woman? Children would have no clue about this. Is this a skeleton of a Hindu or a Muslim or a Christian? We have all these kinds of biases. But it's models like this which brings out the universality of human beings, that at the basic level, we're all the same. Another very nice model is this. You can see this is thin wire. I took thin wire, binding wire, and wound it on a pencil. So it made a small spring. And then I just pulled it out. So it became a spiral. And it's like a spiraling snake. Another very good toy. This is documented in a book called as The Joy of Making Indian Toys by Sudarshan Khanna, who taught at the NID for 40 years. And he brought out this beautiful book by the National Book Trust. I translated that book into Hindi, Sundar Saloni Bharti Khilone. And this is an old capsule with no medicine in it. But what we have put inside this is a cycle ball bearing. So there's a cycle ball bearing inside this, and you shut this. And here, from a transparency, I've made a kind of V channel. I'm going to place this in the channel, and now you can see this. It's a very fascinating toy. Well, also, we just saw that the skeleton. Another way to make a very nice skeleton, this is again documented. And you can see this, that this skeleton can do all kinds of mudras and poses and yoga poses. And how does it manage to do it? If you look at the back, you will find that the arm and the shoulder are stapled together. One pin is on the shoulder, the other on the arm, which enables it to swivel like this, right? You can see this. It can swivel like this. Similarly, so this opens up you just need a stapler, and the possibilities it offers are immense of movement. Very, very nice model. This opens up a new world of toys. And this, for instance, is a rattlesnake. Same thing at the back, you would see that these are joined together by, and the rattlesnake can just curve like this. Just staples. Both these pieces are connected by a staple. One pin on one piece, the other on the other. So this becomes. Now, this is something which you would find, it's one of our folk toys, but a fascinating toy to learn about centrifugal force. If you spin something, it has a tendency to fly out. Look at this. Now, this is, it's difficult to get this, but you could make this very, very simply with, this is card sheet. You can see this like an acrobat with the body and the head are double. So there are two layers. And then you put the arms, and with a needle and a thread, you tie a knot, pull out the needle and put another knot. So the knot makes the hinges. And look at this. And if I spin it with both the hands, it's like a flying man. So children intuitively grasp the meaning of what is centrifugal force. If you spin something, it has to fly out. And you can see this very, very graphically in this. This is a very old toy. It's like old-time carpenters use something called as a bow drill. Now, this is a broomstick. This is an old sketch pen with a thread woven through it. Here's a ball pen refill with a bat on one side and a gauge on the other side. Now, first what you do is you remove this, remove the thread, and then give it half a turn. And there the toy is ready. Now, if you move the drill, you can see that the bird is the nice thing about this is that, well, if you turn it, you can churn curds and make buttermilk. It's like a mixing machine. Well, we make on our website, there are 31 different kinds of pumps you can make. You can throw water to 15 feet. You can make a sprinkler. You can make a hand pump. You can blow up a balloon. I'm not going to show you water experiments. They're not accessible for a laptop, but I'm going to show you something which we did about 25 years back, how to make a pump to inflate a balloon. Now, first, see what this does. And if I keep doing this, well, the balloon will burst. And what is this? Old cycle tube. This is old cycle tube. And what is this? And these are film cans. And what is being done over here is that you take the size. This is the film can, and what we have done is put a bit of tape over here. You can see that it becomes like a valve. If I blow, this is green light. If I suck in, it's a red light. So it's one-way traffic. That's what a valve is. One-way traffic. So this is my suction valve. I put this at one end, and this is the film can bottle. And this is the other valve. So there are two valves, and this is just a pipe for the air to come out, hard pipe. So there are no glass parts or anything, nothing to break. And if you can inflate a balloon with a pump like that, which means it's an ISO certified pump. It's a very high quality pump, and that's what it is. And you can inflate a balloon with this. Very, very nice. And well, hot summer day, you can throw some air in yourself. That's what it is. Now, these are things which we often think that it's the teachers, it's the job of the educators to create knowledge so the children can consume it. I think the children, we are afraid to ask children original questions because children can become knowledge creators. I'll give you one example over here. This is a kind of a municipal school where we worked for 8 years. It was inside the Pune University campus. And this is what the children designed. These are children of 7 years, of class 7th. Now, what they did was, this is an empty paper cup, which we throw away. So they just made two holes, a hole through it, and there are two magnets here, ring magnets. One is on the outside, and one is on the inside. And the magnets, they stick to each other. No glue required. That's it. And this is a cycle, a bicycle spoke. And you just put the bicycle spoke, weave it, and just leave it. This is designed by children of class 7th of a municipal school. There is no reference in literature to a toy like that. Kids are capable of producing original toys. And then what they did was another very beautiful thing. They took, this is a kind of a hoop, a plastic hoop cut from a plastic bottle. And they made two holes across. Weave the cycle spoke, put two magnets, and put this over here. Look at this. It's like a spinning hoop. You can reverse it. Now, this is something which we like very, very much, and they're very good for primary school people, especially for children who are in KG, who are in Montessori. This is the old Hawaii slipper. Now, we know that once a strap breaks, people just chuck away the Hawaii slipper. But the rubber is a very workable material. Our teachers are not skilled in turning wood or turning metal or joining metal and wood together. But this is just with the shoemaker's knife. Now, this is like an inset puzzle, a Montessorian inset puzzle. And this is, so you can see that it's a grayish on one side, it's black on the other. And if you just, you can see, if it is a blind child, that there is no back plate over here. The rubber just sits there, and a blind child can just feel this all over, feel it all over, right? Similarly for the triangle. So about 30 years back, I always thought that the Hawaii slipper was a great gift to education because you could make lots of teaching aids with this. So 30 years back, there was the National Association for the Blind, and there was a competition for making teaching aids for preschool children. And I submitted 3-4 of these. I'm going to show you one more, and which won the second prize. Now, these are, the nice thing about this is that it costs no money at all. And because being rubber, there are no sharp edges. It won't hurt the children anywhere. And these are very well. So we made something like 30 puzzles just using Hawaii slippers. Now, India, in our country, there are 13 million visually challenged children. The largest number of people in the world who can't see happen to be in our country. Because as children, when they're very little children, we're not able to feed them well. They're short of vitamin A, which leads to blindness. And one of the very, very nice teaching aids is, this is designed by a couple, not by us. It's designed by a couple based in Ahmedabad. They had a blind son, and this is called as a touching slate. Now, what I have is on my box is strips of Velcro. Velcro, no, you know, there are 2 strips, one with loops and the other with hooks, and they stick together. But this is just the hook part. I've thrown away the one with the loops. This is just the hooks. So there are millions of hooks. This is my drawing slate. And this is my drawing pen. Now, look at this pen. This is a film can, a bit of rubber, old Renault ball pen, which I've cut at the back, which goes into the rubber. Purpose of the rubber is to join the bottle and the pen together. And over here, I have a bicycle spoke bent into a Z shape. Put a small piece of rubber, gouge it out, make it like a pulley. And what I've wrapped upon it is wool. So this is like this. The wool is, you can see the wool is coming down. And if I can see, the wool is getting wrapped up. Now, what do you do with a slate like this? You hold the slate like this, and you can draw on this. Wool sticks to the Velcro, and then the children can feel it with their fingers. This has been every blind school in the country uses this today. This is something which brings a ray of hope in the lives of those who live in dark. But very, very nice teaching. We also use a lot of these. Now, this is another one. You take an old rubber slipper and punch 3 holes over here. Now, this is if I take 3 pencils. Now, this is like a pencil stand. I can make a pencil stand. And what I'm trying to make is kind of an abacus. Now, if I take a bead goes in over here. This is 1 units. This is 2. This is 3. And the height is such that only 9 beads will come over here. How do I show 10? I take out all these and put 1 in the tens place. If this is entirely full, that would be, this would be 9, this would be 90. And if I put this over here, this would be 10 and 1, 11. If I put 1 over here, this would be 101. This would be 210, and so on. 211, so on. If it's all 3 pencils are full of beads, 999, the maximum score it could pick. The very nice thing about this is that later on, when the children are studying about light, right? If you have a straight beam striking a straight mirror, you have a straight mirror and a beam of light striking it, it strikes and just rebounces back. It retraces its path, so to say. What happens if it's a concave mirror? All the beams bend onto a focus, and you can see the focus over here. What happens if it's a convex mirror? They diverge. Concave mirror, they converge. Now, these are very abstract concepts. If you draw a picture of a curved lens on the blackboard, children find it very difficult to visualize it. But this makes for very good visual. This is what happens in a concave mirror. This is what happens in a convex mirror. Rays diverge. Concave, they converge. Very nice teaching. Well, we use a lot of these Tetra Paks for a number of very, very beautiful things. Now, the Tetra Pak is a terrible material from the point of view of the environment. There is a book of mine. It's called as Little Toys, done by the National Book Trust, which I did about 30 years back, which says that Tetra Paks were just being introduced. Now, Tetra Pak it's a terrible kind of material. If you've seen the inside of a Tetra Pak, you'd see silver. It's actually aluminum foil. So it's aluminum, plastic, card sheet, all fused together. It's a multi-wall laminate. And because there's so many layers into it, for any kind of recycling, you need to separate the plastic and the card and the aluminum, which is very, very energy intensive. So a kind of Tetra Pak would be lying in a landfill for the next 500 years. Because aluminum does not even rust. Plastic takes hundreds of years to decay. Terrible material. So we've designed about 60 toys just using the Tetra Pak, because we feel that it's called as toys from trash, that we must inculcate a sensitivity towards the environment. Don't drink from a Tetra Pak, but pick it up from the roadside, and I'll show you how to make 60 toys out of it. Now, this is the first toy, and this is like a purse. You can see this is a 1 liter fruit juice box, a Tropicana in that case. And so you make a very nice purse. There's a 10-rupee note inside. You can put some coins. There is some Velcro. It's waterproof, and you can put in your pocket. It's a perfect purse for all occasions, eco-friendly purse. You may call it. And house made. Well, but this is, you can see from this is a small one, and Tetra Pak, you cut off one of the sides. So it's just this, push them inside, double this up. And you can see the two internal walls of this, the two internal walls. Those you staple, and you'll get 2 pockets. And there'll be a little flap over here for you to cover this. Put a button, put some Velcro. So this is a small one. The small one goes into the big one. And so you make a very nice purse. Well, this is something called as a inside-outside cube. And you can see this, that it's made of six squares. So you can see this is all, whatever side I see, you would see the colored side. But I can flatten it and give it 2 twists, and then it's silver all over. It's a very nice mathematical puzzle. It's called as the inside-outside cube. Once again, I give it 2-3 twists, and the colored side is out. So this is one. Well, the other is that you can make a very nice. Now, this is a kind of Amul Tetra Pak, 200 ml. It's written over here. If you were to measure the length, the width, and the height, multiply them, you will get the volume of this parallelepiped, which would be very close to 200. So this is you just cut the top, and this becomes an excellent measure for 200 milliliters. And if I just cut this into half, take the height, cut into half, this becomes 100 ml. 100 ml. And again, if I cut this into a quarter, so we can make measures of different sizes, 200, 150. And so this is 100. Now I'm going to just pour water into this. Up to the very brim, how much water is there? 100 ml of water. How much water have I drunk? 100 ml. And then I take my cup and I put my cup. I think all children should be carrying a measuring cup like this in their pocket. And soon they'll get a very good feel for measurement of volume. Well, two more toys before I tell you a small story. And this is something which used to get into mailers, but they're not being made nowadays. But you could make a toy. This is like a woodpecker. See this little woodpecker. There is a small spring and there is a cycle spoke. All the weight is on one side. One of the wonderful toys. This is something which we did about 25 years back. That's time in Delhi. There were diesel buses. Public transport was diesel. And there was so much of particulate matter in the air in Delhi that 20% of the children suffered from asthma. This is before the CNG buses. And so children sneezing all the time, little children. So we devised a small toy. This is a plastic pipe, a plastic straw, and take a pencil. And you make a nice hole. Because the pencil is conical, so the hole which you would make would be a kind of an inverse of a cone. It would be a very rounded cone. There is no sharpener. There is no scissors used over here. So that's it. And then you take ordinary thread, cotton thread, weave it through it, and there is a knot. You can see the knot. This is the knot. This is the knot. So there is a loop here. And cotton has a lot of fibers. And if I blow, if you give it something which costs no money, 10 paisa to make. But if you give it to a child, the only thing a child can do is to blow at it, and they're exercising their lungs, and which is what is required of asthma children. Very, very simple, very, very nice toy. And this is another one. You saw the icosahedron earlier, which was made from the cycle valve tube and matchsticks. But this is again with the Tetra Pak. Such a neat, clean joint. These waste Tetra Paks choke our drains. They are a menace. Very difficult to recycle. But we could make learning much more interesting because it's a terrific material. You can do many things with it. Children can do many things with it. Now, another very interesting toys. This again comes from Sudarshan's book, The Joy of Making Indian Toys. This is the broomstick, the eagle, the coconut broomstick. The poorest house would have it. You take a big one and a small one, and you tie them very, very tightly. And after tying them, you just need a small piece of rubber. It could be an eraser. I've just put a piece of rubber slipper here. And well, if I perch it on my index finger, now this is like the Sudarshan chakra. Now, centrifugal force, centripetal force are very big words for little children. Even the science teachers who teach them have very little experience. They know words, but they don't have experience. But if a child spins this, they would have some inkling as to what centrifugal force is, what centripetal force is. Well, towards the end, I'm going to tell you a very, very interesting story. But before that, we use a lot of newspapers to make caps, because newspapers are terrific material. Now, this is just half a newspaper, and you make this is like the Chacha Nehru cap or the Gandhi cap, just half a newspaper, no glue, half a newspaper. And this is like a national cap. And the nice thing about it is that newspapers are big, and when children are actually folding them, it's like a geometry laboratory. All the polygons which they've learned in the abstract, they're concretely making them. Now, this is a cricket cap. Again, half a newspaper, and this is Sachin Tendulkar's cricket cap. It just fits into the children's head very, very beautifully, right? The nice thing about this is that when you're not using it, you can always fold and keep it in your pocket. And when you go out in the sun, now the newspaper is the cheapest paper available. And if you can show possibilities, we make 20 different kinds of caps just using the newspaper. And this opens up a whole new world for children. We don't need to buy toys. The best toy in the world is the one which the child herself has made. In the 30s, it's Rabindranath Tagore in Shantiniketan who pointed out. He said the best toy is the one which the child completes. If it's a ready-made toy, well, the child is not interested in this. It's the child's participation. The toy is a part of the child, and the child should assemble it and make it work. Then it becomes a child's toy. Then something happens, the child will be able to repair it or do something with it. Now, in the end, I'm going to tell you a very favorite story of mine. And it's called as the Captain's Hat story. And this is, you take a full newspaper, I just fold this into half. And this is the story of a captain of a sea-going ship. Now, you see, a ship sails into the wide seas, and it takes several weeks, several months before it lands on another port. And usually there are, the passengers like it the first few days, perhaps it was the first sojourn into the sea. But after a couple of days, all they see is the wide blue ocean, not a patch of land, not a tree. All of them become bored. They become seasick. There is a technical term, seasick. Now, the captain of the ship, his name was Topi Shankar. Why Topi Shankar? Because he had a suitcase full of different kinds of caps. So when Topi Shankar saw that all the passengers were getting bored, he invited all of them on the deck. And he said that you sing and dance, entertain yourself the whole day. I'll provide you with good food and drinks. Now, Topi Shankar had a suitcase with different kinds of caps. And every day he would wear a new cap and join the regalia. And the first day, it's a huge umbrella cap. If the captain is standing on the deck, it protects him from the scorching sun. It protects him from the rain. And at night, when the passengers would go to sleep, Topi Shankar would take the same cap and give it one more fold. And the next day, well, he's wearing a new cap. Now you can see this cap. This is like a fireman's cap. Firemen wear a kind of very designer cap because there's a chute at the back. They work under very dangerous circumstances, hazardous circumstances. They go into a burning house, and if some rubble falls, it must protect the spinal cord. That's why the chute at the back. The second one is a fireman's cap. And second night, he would give it one more fold. And the third day, it would be an explorer's cap, a Robin Hood cap. So first is a huge umbrella cap, second is a fireman's cap, and third is the adventurous cap. And the third night, Topi Shankar would give it two more folds. And the fourth day, he'd be wearing a new cap. And this is a very, very famous cap. In Maharashtra, I'm talking to you from the city of Pune, which is Maharashtra, just about 150 kilometers from Mumbai. And Mumbai makes, all of Bollywood films, the biggest film production center perhaps in the world. And all our Bollywood films, the policeman wears a cap like this. And in Maharashtra, it's called as a Pandu cap. And it's been catapulted to international glory. So four huge caps. First is a huge umbrella cap. Second is the fireman's cap. Third is the shikari cap or the adventurous cap. And fourth is this Pandu or the policeman's cap. And we must not forget that Topi Shankar, after all, he was a captain of a ship. And that's a ship. And everyone was enjoying the journey very much. Good singing, good dancing, good food, good drinks. But suddenly, there is a storm. There are black clouds and starts to pour. There's thunder and the sea is on fire. A huge wave comes and slaps the aft of the ship and knocks it down. Now the ship is sinking. Another huge wave comes and slaps the front of the ship. The ship is broken to pieces. And now there is the triangular portion of the ship is called as a bridge. And a third huge wave comes and slaps the bridge. And now the ship is broken to smithereens. And the ship sinks to the bottom of the ocean. The captain, Topi Shankar, has lost all his suitcase, his caps. All that remains is a little life jacket. Thank you so much for being with me. And I think I would request Fasia, if some of the teachers have some questions, I'd like to answer them.
Sir, thank you so much. That was an incredible session. In the chat box, all I could read was, amazing, creative, innovative, useful, valuable. These were the comments that I was scrolling down in the chat box as you were speaking, sir. Thank you so much on that. The one main question that's been asked, repeatedly, which we have tried to answer, but then maybe you can also
sure.
Is that a request for the link to tutorials to these videos.
Okay.
So.
Yeah. No, you can go to my website, arvindguptatoys.com.
Yeah.
And there would be, of course, books are there, and there are photos. Each toy is being documented with instructions and photos. And in the end of the photos, you can go to the video for that and click and go to the video. Or else the last one is videos or videos on toys from trash. You can go there and in 20 languages, you will find all the videos. They're all on YouTube. We've had a lot of visitors to our site. And they're on all languages. The nicest thing is that we collaborated across the board. Government organizations, non-government, private schools, anyone who was enthusiastic. As a matter of fact, the Telugu ones have been dubbed by a school in Vizag. And it was a private school. They would bring the children to our center, and very inspired man. He said, "What can we do for you, sir?" And he runs 3-4 schools over there. I said, "Look, who is there to do dub our videos in Telugu? Please do it." 800 of our videos in Telugu because of this person. Similarly, in Punjab, the person who owns the DPS school in Pune, in Patna, in Coimbatore, in Ludhiana, Mr. Sanjeev Kumar, a very nice man, a very progressive person. And he said, "How can?" I said, "Look, sir, you have a school in Ludhiana, and who would do our videos into Punjabi?" So again, walk the talk, 800 videos into Punjabi. So we have this. We have 350 videos in Spanish. There was a postdoc student. She came from the Dominican Republic in an adjacent institute. She came to our center, and she saw all these toys. And she said, "Look, sir, I come from such a poor country. This is what my children need." It hurt. This is Dr. Brizio Cana Flaca. It hurt her very deeply. Spanish was her mother tongue, and she dubbed million Spanish spoken in 26 countries, and millions of kids across the world have seen them in Spanish. So they're all accessible.
Yeah. We have said in our replies to all the questions that they can find all the information that they're looking for if they go to the website and all that. But there have been a few specific questions which I would like to relay to you. A specific question that was asked was the principle behind the pencil spinner, sir, that you showed, which is fantastic.
Well, I must tell you, the pencil spinner it's 100-year-old. It has foxed every scientist. There are 6 major research papers in this toy. And that's why it's not in the NCERT. NCERT doesn't know the answer, right? No one knows the answer for it. So a child is at the same level as the biggest scientist. And you can do all kinds of things in this. There have been many kinds of variations. For instance, you see, what people have done is that I have this and I put one more thing over here. You can put 2 propellers. One propeller here, make a T out of it, make 2 propellers. One you can make go clockwise, one you can go anti-clockwise. You can, by rubbing, you can turn the But there are all kinds of variations. It's mind-boggling how it does that. But the greatest takeaway from this is that with this humble thing like a pencil, and this is so nice because our classes are so goddamn boring. When children get fed up, they can at least take it out. When the teacher is looking, they're writing something. So if you want to survive school, teach them how to make it.
So true, so true. Sir, another specific question that came up a couple of times is that, sir, can I use any kind of paper? Do I need to look for a certain kind of thick paper?
No, not at all. We use, as I said,
I don't know, a lot of people have asked
these are newspaper. These are all cut from newspapers, magazines. If you take Outlook or Frontline, one of these magazines, these are all imported newsprint. Very, 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 very good quality newsprint. The newspaper magazines have. So cut them into little squares. We had a pile of squares in our center. If a child folds a rabbit or a bird, take 100 with you. Try this out. We can afford to give them because this is newspapers are 10 rupees a kilo, magazines go for 4 rupees a kilo, right? So this is the cheapest paper. And then newspapers, you can make big things out of newspapers.
Okay, so I've sort of collated all the questions which point to this one thing that teachers have asked in various ways. They have asked this, but I think what they want to know from you is ideally, if they are to do these experiments in their classroom, what would you say should be the role of the teacher? Demonstrate it to them, or collaborate with the students, or just give the instructions and sort of back off and let the students do it. What would you say?
First, I think the best teacher in the world is the one who says, I don't know it myself, right? They are the best teachers. People who flaunt the degrees, have a BA, DMed, PhD, very long tail. You don't cut much ice with children, right? Yeah. Make them collaborators. Tell them, I don't know it. Let's discover it together. And let them join the club, right? And if, teacher is instructing, giving materials, they're very disciplinarian teachers I've seen. You will go bonkers. Because, if there are 50 children in the class, there should be, because the activity itself is so child-friendly and the children are so glued to it, take them on board. It's the children's team. They should sit in teams. They should be helping each other with the teacher just going from one group to the other. The ones who are better with their hands should help those who are not so good with their hands. And this is how it will work. But it will be magic. The class will be quiet because there's such life-giving activities. True. Right? That's it. And very affordable activities. Never buy. There is a whole kit culture. I must also tell you this. All kinds of suppliers, middlemen, intermediaries, trying to push all kinds of junk. And schools have become, graveyards for all kinds of this high-tech junk, right? And one must refrain from this. Buy straws, buy magnets, buy generic material, buy scissors, buy all kinds of things. Teach children, ask them to bring old slippers, get cardboard. A good school would put 5 cartons. Bring old newspapers. Parents don't mind sending out old magazines, right? Old, tea boxes, cardboard boxes, plastic boxes. We live in a consumerist society, which is anyway producing so much of junk. So use that material. Even if something goes wrong, it's not the end of the world. Yeah. Do it again. Yes. So that's the way to go about it.
True. I think that answers in a lot of questions that were on that topic, sort of, yeah. That's the one thing that a lot of teachers said that, very innovative. We have learned so much today and we want to do this in the classroom. So what would Arvindji say our role should be? What should a teacher's role?
Teacher's role is that of an initiator, excite them, show them a motor, and then show them how to make it. And then put them in teams and go ahead, do it.
Yeah. And of course, there have been a lot of comments which say that in this age of mobiles, and when our kids are stuck to the screen all the time and all that, it would be so wonderful if you could pull them away from that and get them to do something with their own hands, and that they're looking forward to trying all these in their classrooms. Sir, if I started reading out all the comments that have been scrolling in the chat box, it would only be adjectives, like amazing, incredible, and thank you so much and all that.
I think there is the antidote to screen addiction is doing activities with your own hands. And we have 11, we never call them science experiments, we call them toys. Because this science is taught in such a horrendous way, maths is taught in such a horrendous way, kids say, no maths for us. They may be very good at that, so we call them toys. And every child, play is universal, and play is such serious business. Every child wants to play. And I think play, they will learn, they will discover so many things. Children learn so many things without being taught. We don't need to teach everything to the kids.
Yeah, that's there. Sir, most of the questions are on these lines. So okay. I think we have kind of answered a lot of questions that when you said this and when you answered this. We just want to thank you from the bottom of our heart for doing this session for us. We really want to see you again as a presenter on Orient BlackSwan ONE. And thank you everyone, all the teachers for participating in today's webinar. We would love to hear from you. So please share your feedback with us. So that's about it from this webinar. A good day to all of you from Orient BlackSwan. Arvind ji, thank you so much again. Thank you.
My pleasure. Thanks.